Hey everyone, how are you? In this video, I'm going to talk about a great auto integration tool for your coding workflow named n8n. And specifically, I'm going to cover LangChain's integration with n8n. So basically, to bring in LangChain as a language agent and its awesome ecosystem of all the large language models, you no more have to write codes. You can pretty much just do drag and drop to implement the awesome workflow of LangChain module. For example, you can do chatting with your PDF, summarizing from multiple web pages, get the gist of YouTube videos, do question answer on your vector databases, and many more stuff just by doing drag and drop with n8n. So right now I'm looking at their official website and you can see that in GitHub they have a huge 33,000 stars. And but there's so many clients, so many big corporate names who have already integrated n8n into their workflows. So you can just go through the sites. But remember, in this video, I'm going to focus mainly on LangChain's integration because n8n is in business for quite some time. And many of you probably already know it, how to integrate Google Drive or Google Sheet or a plethora of applications for auto integration and do automated stuff or automated execution in your coding workflow. But in this video, I'm going to talk about their very new integration with LangChain so that you can use the power of all the large language models automatically without writing any codes. So yeah, this is their GitHub. You can actually go through the source code to, if you are really interested to go and dive deep. And first, you need to install it in your local machine. Of course, you can directly run it in the cloud, but in that case, you have to sign up and create an account. I think you may have to provide your credit card details for a free trials. But in this case, I'm just going to install it locally. And their documentation is pretty exhaustive. You can just go to the installation section of the documentation. And there are quite a few options. You can use npm, you can use Docker, or you can use server setups. So for the npm, it's just for trying it, you can do npx n8n. That's a simple command. That's all you need to run. And for installing globally, you have to do this npm install n8n-g. And yeah, and then you can launch it by running this command n8n, n8n, yeah. So it's pretty simple. And in this particular case, I have installed with the Docker because currently I'm running it in my Windows 11 machine and I have a Docker desktop. And just with these two commands, you can launch it and start working on it directly. And remember, when you run these Docker commands in your machine, this command will download all required n8n images and start your container and expose a port that is 5678. And then you just go to your local host 5678 and start running n8n. So in this video, the plan is to implement and check a couple of use cases of n8n. And the first use case that I'm going to see is what you are currently seeing in this picture. So it's a running n8n instance in my local machine, and it's running in my local host, as you can see right here. And so basically, this is the whole diagram. And what I'm doing here, that is, I'm integrating LangChain here. So this is a classic example and the most popular example of the application of LangChain in an industry, which is doing a chat with a PDF. So I have a PDF, a long PDF, so you cannot just pass it to your chat GPT or GPT 3.5 or GPT-4 API because it's a very long context window, probably have 200,000 or 300,000 words or tokens. So you have to integrate LangChain to do a chat with this PDF and to get the answer of your questions from this PDF. So basically here I have integrated my Google Drive because the PDF is in Google Drive. Then I'm downloading that PDF from Google Drive through these n8n application. Then I am converting the PDF into a vector store and storing that vector in PineCon, which is one of the leading supplier or provider of vector store. And then I am doing passing that to OpenAI embeddings, and then a binary input loader with a document loader where it will chunk my whole document into so many different chunks, because OpenAI API cannot read the whole document like I was saying. So you have to dissect it into many chunks. And then once all this is done, then again I am asking question on that document and getting answers from the document. So this is the whole workflow, and that's what we are going to build now. All right, now to create a new workflow, and just go to the workflows tab and then add workflow. And you have an empty workflow, absolutely. So let's first create it, and I'm choosing LangChain AI nodes. This is the new addition that n8n made. So just click here, and the first thing for my, like I said, that I want to do a chatting with PDF. So I need to get the PDF first. So I've already uploaded the PDF in my Google Drive. And now I need to download that. So first I need to integrate the Google Drive here. So just search Google Drive. And the thing that I need to do here is download file. As you can see, there are so many actions you can do with Google Drive. Create shared drive, get shared drive, upload file. But here I need to do the download file. All right, now here a couple of things you need to remember. To integrate your Google Drive, the first thing you need is set up your Google Cloud account. And actually, if you just here, you can see parameters tab and also the docs tab. Parameters tab is where you have to actually work and put your Google Drive account details on OAuth2 API, etc. But if you are doing it for the first time, I really recommend go to the docs and read their docs. It's pretty exhaustive here. So what basically they are saying that for creating your Google Drive, integrating your Google Drive with n8n, you need few things, and you need a Google Cloud account, you need Google Cloud Platform project. That's the main two things you need, and then you have to set up an OAuth and create the credentials. And actually all these also direct you to the relevant Google Cloud accounts documentation as well. So I just followed these link and from the n8n documentation, and that will take you to the official docs of Google Workspace or Google Cloud account. Remember, if you have never worked with Google Cloud, you first initially have to activate your account, which will need debit or credit card, and you will get a 90 days free credit of $300. You will not be charged anything at all during those 90 days for your Google Cloud, so nothing to worry. And then n8n documentation says that they recommend this OAuth2 instead of this Google service account. So there's two ways to establish the credentials. One is OAuth2 and another one is Google service account. And I initially set up the service account, but it did not work properly. And that was kind of expected because the documentation of n8n clearly said that they recommend OAuth2. So that's what finally I set up. You just followed this instruction here. That's a long page, but actually it's quite simple. You just go to your billing account and then select OAuth setup, and it automatically will take you to the next steps. So nothing to worry. You just follow Google Cloud's step-by-step process. And once you set up the OAuth2, you will get your client ID, client secret ID. All those things will be needed when you come back to your n8n app and you choose your create new credentials. That's where you're going to need those Google Cloud's client ID and client secret ID. And there you just put it. And as soon as you put it and put the relevant user email, that because after you put all these new credentials, also you have to sign in from here. And for that, you have to choose a particular Google email ID, that is Gmail ID. And that Gmail ID should match when you set up your OAuth2, because during the process of OAuth2 setup, and there's a particular step where you have to give a particular user email who will use these OAuth2 in the client app. And that is the email that you have to give when you choose your new credentials here. So anyway, that may take probably 10 to 15 minutes for you to set up. So in my case, I have already set it up. So my Google Drive account is already connected here. And so once I choose the resource as file, then operation as download, because I'm going to download a PDF file, and then I choose the file as from list. There's other option as well, by URL or by ID. In the Google Drive, for each and every file and folder, you have an URL, you have an ID, but here I'm just simply choosing from list. And as soon as you click here, it will automatically show, it will automatically fetch the number of files that I have in my Google Drive. So here this is the research paper that I wanted to do chatting with LangChain. So I choose this, and that's it. And let's now just click outside. So my Google Drive account, I have not note that I have not yet executed it, because I'm going to execute it after I set up the entire thing. But if you want to execute, you can execute even now for just clicking on this button. Okay. So now proceeding further, as you can imagine that I am kind of building one chain after another. That is, this will be executed, then some other execution will go on. Okay. So the next one is I want to add the vector store, that is from LangChain. The whole PDF that I just downloaded from my Google Drive, that needs to be converted into vector, and that needs to be stored. So for that, let's go to vector stores, and there are quite a few options here. In-memory vector store, PineCon insert, PineCon load. So remember, they are still building it. So you will very soon probably will see many other vector store options like Weaviate or so many other. So for now, I'm going to choose is PineCon insert. All right. Now here again, for the first time, you have to set up your credentials, and here the credential is much more easier compared to the Google Cloud, because all you need is a PineCon account API, and that is all. And in my case, I have already set up the API, so that's what I'm choosing here. I'll just show you create new credentials. This is the screen, and here API key is the API key that you will get from PineCon. And environment, that's actually the GCP session which region it's running. That's that info. So both of these you will get from PineCon. So let's just quickly go to my PineCon screen here. So this is my free tier of PineCon, and as you can see the API key, there's a tab. You will get your API key from there. And the first thing, you have to create an index. And so when you try to create an index, you have to give a name, you have to choose a dimension. For the dimension, I chose a very simple one, 1536. That is a vector dimension actually for creating those vector stores. And cosine, that's by default, and I left it at cosine. You can choose dot product or Euclidean based on a different situation, but cosine is the most common one for creating for calculating the distances between various vectors. This is a metric based on which two vectors will be compared, that whether they are similar or not. All right, now when you create a new index, so whatever the new index you create here, the name should match exactly what you give here, because here as well you have to give your PineCon index. All right. And also you from these indexes, like you can see that the environment here automatically it chose Asia Asia Southeast 1 GCP free, and that's what you have to put in here when you are choosing your credentials for PineCon. So by default it has chosen US Central, but you have to change it to whatever you see here in the PineCon. All right. Okay. After you input those two, your credentials will be ready, and your PineCon actually will be ready. And you can, after you put those PineCon index and PineCon namespace is something, you can choose whatever you want here. And then you can actually execute the node to see that your PineCon is working properly. All right. So now here, as you can see that my PineCon node is already here, but there's a warning. So what is those two warnings? That parameter PineCon index is required, no node connected to required input document. Yeah. So PineCon, these needs two subnode kind of things. So one, as you can see, there's two plus icon here. So I have to complete them as well. The first one is document, second one is embedding. So let's do that one by one. First, you click on document, and because here I'm dealing with PDF, that will come under these binary input loader. Now, GitHub document loader, JSON input loader, these are two other options that LangChain gives. But in my case, my PDF will be under this binary input. So you click on that, and from there you choose PDF loader. And obviously you can see all the different loaders that LangChain gives you the option for: CSV loader, docs loader, EPUB loader, text loader. But here I'm going to choose a PDF loader. Okay, and there is nothing to execute here. It is just a sub node. So I just click outside to come out of it. Yeah, so now we can see that this document is being connected here. And the next one, I have to choose embedding. And embedding, currently you are only seeing embeddings OpenAI, and that's where again you have to connect your OpenAI API account here. Mine is already connected, but if you're doing it for the first time, just very simple, create new credentials. All right, and you give your API key. That's as simple as this. Here, connecting the OpenAI API is the simplest one here. You don't even have to give organization ID here. That's an optional thing. So yeah, after you give your API key of OpenAI, it will be connected, and just click outside to come out. Okay, so both of them is connected now. And here again, I can see another warning sign, no node connected to required input text splitter. That is expected because we can see there's a plus sign here, text splitter, and I have not done anything there. So let's just click on that. So again, if you're familiar with LangChain terminology and the LangChain ecosystem, you know that LangChain actually splits your entire text. So here my original PDF may contain something like probably 5,000 words or 200,000 words for that matter. And the entire thing cannot be passed to in a single window to OpenAI for analysis, right? So that's why we need to split the text. And the most common one in LangChain is the recursive character text splitter. There's other option as well, character text splitter and token splitter. And just would like to mention a couple of things about this recursive text splitter. So basically this text splitter operates based on a list of characters that serves as delimiters or split points within the text. It attempts to create chunks of text by splitting these characters one by one in the order they are listed until the resulting chunks reach a manageable size. So it splits document recursively, meaning by different characters starting from new lines, then spaces, then empty characters. The advantage of this approach is that it tries to preserve as much semantic context as possible by keeping paragraphs, sentences, and words intact. Meaning the words within chunks are often closely related semantically, which is beneficial for any natural language processing task. And like I said, there are a couple of other techniques as well to do the text splitting, but the recursive character text splitter is the most common one used for general documents such as text or mix of text and code and so on. Here, for our purpose, it's just perfect. So I'm going to choose that one. And here you have to mention your chunk size and chunk overlap. So I'm going to use GPT 3.5 Turbo. So I can very well, you know that by default it gives the 2000 words, 2000 tokens of context window, right? So 2000 token means I probably will have 1500 or 1600 words maximum. So for that, I keep at maybe 800 because I have to take care of both the input and the output from GPT 3.5, right? And chunk overlap, you can mention for 800 token size, you can mention 50. Now, here's another thing. If you are subscribing to GPT-4 or the paid version of GPT 3.5 API, then you will have access to 16K context window, right? So 16 with 16K context window, you can set the chunk size to much higher value. You probably can set it at 4,000 here, or here it may be maybe 400, something like that. But for our purpose, I'm just going to do it at 850 because the API that I'm going to be using, GPT 3.5 Turbo, that has 2000 context window. All right, click outside. So yeah. So now everything is ready. I can run the entire workflow by just clicking on this button. So let's do that. And you can see that as soon as I ran, it gave me the workflow has issues, PineCon insert parameter, PineCon index is required. So let's see what's the problem here. Yeah. So I did not put the PineCon index name. So what was my PineCon index name? That was this one, my index hyphen n8n. My n8n. All right, and also give a PineCon namespace. So my n8n sp. Okay. I can choose. You can choose clear namespace. Okay. All right, now run again, that is execute the entire workflow, and you can see it has started working here. Yep, that executed just fine. PineCon insert is getting executed, and that's it. My entire workflow got executed. Now, one quick thing before proceeding further, the documents that I'm reading here that is the document that I downloaded from Google Drive and which I submitted to PineCon and then to OpenAI embedding is this one. It's just a two pages from a long research report. So the heading of these, it was published just very recently on 25th September 2023, and it deals with disinformation detection, an evolving challenge in the age of LLM. So it talks about how different, I'm talking about this document particularly because now the next steps of the work that I'm going to do with n8n and LangChain, you need to have a context that what the document is doing and what kind of answers I'm getting from OpenAI, and how OpenAI, whether OpenAI is the answers that OpenAI is giving, whether they make sense. So this document is about this whole research is about this disinformation of AI and how the simpler models like Roberta and all the previous model that were insufficient to handle all the to handle the checking whether AI is producing misinformation, and what are the solution possible in these challenge that when AI will produce larger LLM will produce many misinformation. So yeah, so that's the document is about. Now let's go back to our LangChain integration. And coming back to n8n, we can just quickly check the various nodes that just got executed perfectly. So let's check out this PineCon node here, double click on it. And on the left, you will see the input to the node. In this case, it is just a PDF file which came from Google Drive, and you can see all the details. For example, the MIME type is application PDF, file size is 285 KB, etc. And on the output, we see what this particular node did. So the job of this node was to create chunks and vectorize it with PineCon, and that's what you see here. And within the metadata part, you can see each chunk. For example, the first chunk that shows here, I think that will show the line number here. I just saw it. Yeah. For example, here, page number 1, lines 1 to 21. That's your one chunk, which is this one. And then if you go to the next chunk, that's from line number 22 to 36. That's this chunk. So there are so many chunks that it has broken the entire document to. All right. Just click outside. Okay. So this part is over. Now the next part. But before proceeding to the next part, let's quickly recap what we did till now. So here we are using LangChain, PineCon, and the OpenAI embeddings to create embeddings of our PDF document. We then use PineCon to create a PineCon index and add our document to it. And those indexes can be seen by double clicking on the PineCon node here. And just to say what PineCon index is all about, so a PineCon index refers to a structure that is used by PineCon to index and organize the vectors that are stored within that database. And index employs the advanced techniques such as approximate nearest neighbor algorithm, dimensionality reduction for search efficiency, and many more stuff internally. And using an index in PineCon facilitates rapid similarity searches by quickly identifying the vectors that are closest to a given query vector, which facilitates an efficient information retrieval. That's the whole purpose of doing the PineCon node here. And after this is done, finally, in the next step, we will use this PineCon node or PineCon indexes to query our index and get back the most similar document or most similar answers to our questions. Alright, so to do that, I go to LangChain AI nodes again, and now this time I select chains. And within chain, I need this one, vector store QA chain. This will perform a question answering operation on a vector store based on the input query. And we can see there are other chains as well. For example, LLM chains, retrieval QA chain, structured output chain, summarization chain. I will use the summarization chain in the next part of this video. And structured output chain, this one processes input text and structured the output according to a specified JSON schema. No, we don't need that for this purpose because here we already have the vector and we just want to do question answer on that vector store. So let's just select that. And remember, one of the most powerful attribute of LangChain is being able to create these chains. So this is a unique offering from LangChain amongst its many exceptional attributes, that chains permits the integration of various components to craft a unified application. For instance, a chain can be developed that accepts user input, processes it with a prompt template, and subsequently transfers the formatted output to a large language model for further computation. In this particular case, what we are doing right here, the chain is going to process the vector store and take our query and get the answers from those query from the large language model. And in this case, the large language model is OpenAI, chat OpenAI. Now what you see here, these top K and query, I don't need to change the query, this JSON anyway, because it's just going to take from the input. And a quick note on the top K, by default it is taking the number 4. I actually don't intend to change the number 4 here, let it be there. But let's understand the significance of top K. So top K sampling restricts a token selection to the K most likely next tokens. Because as you know, the underlying architecture of OpenAI is transformer model, and this transformer model at the very basic, at the very nuance level, it's about predicting the next token. So this top K is about that. That is, it's a selection to the K most likely next tokens, and after computing the logits and applying the softmax, etc., the model will zero out the probabilities of all tokens except for the top K tokens. That is a mathematical significance internally. You don't need to understand these to operate n8n or LangChain at all. You just I just told you so that it makes sense that what top K is all about. And by default here it takes a value of 4, that is like the most frequently used value. So let's just keep it at that. Yeah, let's bring it here. All right, now we can see that there's further 2 subnodes here, just like we had for our PineCon. That is, we had to include binary input loader, that is a document input loader, and the OpenAI embedding. Here as well, I can see one for model, one for vector store. So let's do that, model, and I'm going to select chat OpenAI, and here again my credentials has already been taken, which has OpenAI API here. And for the model, there's many selection. You can select the 16K, in which case it's definitely better because the context window length is 16K is better. If you have access to that, and but of course that is a slightly higher priced for this purpose because our document is relatively small, and I have also chosen a smaller chunk size. So I can just select GPT 3.5 Turbo, which is I think 4K or 2K context window, but that will be sufficient for this purpose, for this demo purpose. But in actual cases where you have a long document, you definitely are better off by selecting 16K. Alright, and options here again, I have to choose, I want to choose sampling temperature, and let's put it 0.1. Now once again, what is this temperature sampling? So temperature sampling affects the probability distribution over the vocabulary when generating the next token. Specifically, it adjusts the logits or pre-softmax values computed for each token. Now that's a mathematical explanation, but basically what it means is that the higher the temperature, the more creative or more innovative GPT 3.5 will be to generate your answer. But in this case, I don't want it to be creative, because I already have passed the documents and I want GPT 3.5 to specifically look into the document and give me the exact answer. So I want it to be least creative, and that's why I am giving you a low value here. So basically, as the temperature approaches 0, the model becomes more deterministic and is more likely to pick the most probable token. And the next thing I have to supply to vector store QA is the vector store. And we can see right now there's a couple of options. Supabase zip vector store, but we have used PineCon here, so I'm going to use PineCon load. And PineCon API account has already been taken. If you have not set up your PineCon API account, just create one account and get the API and put it in here, and that's just a matter of a couple of seconds. And PineCon index, you have to mention the same index name. Our index name was this, my index n8n. And what was my PineCon namespace? I forgot that. Let me check. Yes, that was my nt. Just copy it from here and go back here. Right. All right, so I am set up. Okay, yeah, I have to choose the embedding as well. Embedding again, I previously as well, I used here OpenAI embedding, and here as well, I'm using OpenAI embedding, and there is nothing to select here. Okay, so I'm all done here. And then I need to add a chat trigger here. So just go to LangChain AI nodes and manual chat trigger. All right, yeah, and let's move it here and connect it to this like that. All right, now I just click on this chat button right here, and I have my chat window. So here I want to ask question. Type in message right here. Now remember, in our document, the original PDF document, which was about researching whether AI generated disinformation is a problem, and how large language models of the recent times can check AI disinformation. Now that document talked about how the earlier models like BERT, which are much more smaller models, whether they could check the AI disinformation. So the question that I'm going to ask is that, are smaller language models like BERT good enough to detect disinformation in AI? And send it. Let's see. Awesome. It took a second, and let's see the answer. So this is on the left side. What you see is the answer under response and then text. So research in AI generated disinformation detection has predominantly focused on smaller language models like BERT, GPT-2 and T5. These models have been effective in detecting disinformation to some extent. However, with the advent of large language models like GPT-3, which have billion scale parameter, the complexity of disinformation detection has escalated. There is a gap in the literature addressing the detection of disinformation generated by LLMs. So while smaller language models like BERT have been useful, they may not be sufficient to detect disinformation generated by LLMs. Exactly. That is exactly how the research paper proposes, that how the smaller language models were not good enough really to detect disinformation. So yeah, so this is really working. You can ask any number of questions in here, and the whole process will go on. That is, the vector database in PineCon will be hit, and then proper answer will be fetched for you. So yeah, you can see the whole question answer of PDF I just implemented without writing a single line of code. It is entirely drag and drop. Alright, now let's do another quick one, which is conversation agent. I just want to do a conversation with an agent. So let's add my agent, conversation agent. Yep. And here I can see that there's quite a few supplemental nodes here. For example, I have model, memory, tools, output parser. So for models, let's add that. Chat, OpenAI, and the rest of the things are just perfect. OpenAI account, GPT 3.5 Turbo. Here again, you can choose whatever you like. Let's select 16K here. Okay, and option, add option. Again, sampling temperature. Here, I just want to give it slightly higher temperature, 0.5. And okay. And next, I want to add the memory. Click on that, window buffer memory. So I have other memories option here, Redis chat memory, which is a third-party memory, then Motorhead, Exata, Zep, but Windows buffer memory is like the most common one while working with LangChain. You can actually go to their documentation in LangChain to read more about that. So here they talk about conversation buffer window memory. So basically, there are different types of memories in LangChain. A best practice when developing chatbots is to save all the interactions the chatbot has with the user. This is because the state of the LLM can change depending on the past conversation. In fact, the LLM will answer to the same question from two different users differently because they have a different past conversation with the chatbot, and therefore it is in a different state. And in the context of a chatbot, customers would expect it to remember the things they talked about in the earlier part of the conversation. Otherwise, it would be annoying to have to tell the same things over and over again. So by providing memory types with different features, LangChain AI makes it easy to implement memory components into your applications. And that's exactly what this conversation buffer memory is all about. So what the chatbot memory creates is nothing more than a list of old messages, as simple as that. So these old messages are fed back to it before a new question is asked. Of course, the LLM have limited context windows, so you have to be a little creative and choose how to feed this history of messages back to the LLM. The most common method are to return a summary of the old messages or return only the latest n number of messages that are probably the most informative. And the different memory that LangChain provides are conversation buffer memory, then conversation buffer window memory, conversation token buffer memory, conversation summary memory, and there's even few more. So let's quickly talk about these one conversation buffer window memory. So here LangChain provides several features to control the memory size. One of them is a conversation buffer window memory, which stores the previous k messages, and the k value is determined using the k parameter. And the first benefit of conversation windows buffer memory is the reduced token usage. By storing only recent interactions, that is the top k or the previous k number of messages, chatbots can conserve memory resources, resulting in faster response times and lower computational cost. This efficiency is particularly useful when dealing with large-scale conversational systems. And remember, OpenAI will charge you by the token. So the less number of tokens you remember, the lesser will be your cost for OpenAI embedding. Next benefit is contextual relevance. By retaining recent interactions, conversation buffer memory enables chatbots to access relevant conversation context only. This context is crucial for generating coherent and personalized responses. Chatbots can leverage this memory to understand user intents, reference previous information, and maintain a smooth conversation flow. Next, I am going to add a tool. Let's just add Wikipedia. You can see that there are so many options. If you are just doing mathematical calculations and you want to chat about your calculation, you can add calculator tool. For your questions on just code, you can use code tool, SARP API is another great, powerful API you can use for chatting. And then Wikipedia Wolfram Alpha workflow tool. In this particular case, so Wikipedia is the best option for me because I just want to have general knowledge chatting with it. And the last one is output parser. And the last one is output parser. For now, I'm just going to select the simple one, item list output parser. Okay. And okay, I need to also add the chat, the manual chat trigger, right? Yep. So yeah, let's just yep. Now let's start chatting. The first question I'm going to ask is, when did GPT-3 come out? Send. Awesome. GPT-3 was released by OpenAI in 2020. Can you give me the exact date? Exact month, rather. And okay, in this case as well, it just gives me it was released in 2020. Next question. Give me Barack Obama's tenure as the 44th president of the United States. Awesome. From 2009 to 2017. Who was the next president? The next president was, after Barack Obama, was Donald Trump. Can it answer when? Who was next? Who was after that? Awesome. It also remembered all the sequence and just perfectly answered Joe Biden. And on the right side, you can just look into some of the metadata of these chatting. So you can go chat OpenAI and you can see all the minute details of various option 1, option 2, all these things. Then you can Windows buffer memory, action, chat history. Okay, these are just internal parameters in case you are interested. For example, if you just click on the Wikipedia tool right here, you can see how my internal chat tool was querying Wikipedia. So they were querying this page, list of President of the United States, and the response that it got, and it answered from that response. And also, if you just click on the OpenAI tab right here, you can see the details of the underlying JSON. So this is a raw JSON format. We can see, for example, the content here. Do your best to answer the question. Feel free to use any tool available to look up relevant information only if necessary. However, above all else, all response must adhere to the format of response format instructions. So these are the internal instructions given by LangChain to OpenAI while sending it the queries. And yeah, so we can see all our human, that is, I asked when did GPT-3 come out, AI responded this. So let's go to the raw JSON format again. Yeah, and it goes on for each of the for each of the question. It has human AI, and all the details. Response format instruction. Output a JSON markdown code snippet containing a valid JSON object in one of 2 formats. Alright, so that was chatting with a conversational agent using LangChain AI, and again, as you saw, that we did not have to write any single piece of code, and it all happened by just dragging and dropping. Alright, the next thing I want to do is creating a summarization of a PDF document. So let's create the node, LangChain AI node, and first thing I need is a Google Drive because I need to download the document first. So it's the same steps I did for the first node where we did a question answer on the PDF document. Okay, so here I am. Google Drive credentials is already connected here. Resource file, operation download. Let's see. Yep. That's the one. And then yeah, just click outside. Next, I want to add the LangChain chains and then summarization chain. Okay. Now here we can see run once for all items, and in the type we have three options: MapReduce, refine, and stuff. Let's quickly get to know them. So you can actually go to LangChain's official documentation to read more about them. So when you're dealing with documents, you have stuff, refine, MapReduce. These are the three main types that we just saw here: MapReduce, refine, and stuff. So let's quickly see. Stuffing is the simplest method, where you simply stuff all the related data into the prompt as context to pass to the language model. This is implemented in LangChain's as the stuff document chain. The pros are only makes a single call to the LLM. When generating text, the LLM has access to all the data at once. But on the con side, most LLMs have a context length, that is a context window length. And for large documents or many documents, this will not work, as it will result in a prompt larger than the context length. Then the main downside of this method is that it only works on smaller pieces of data. Once you are working with many pieces of data, this approach is no longer feasible. The next two approaches are designed to help deal with that. MapReduce, that is the next method. This method involves running an initial prompt on each chunk of data for summarization task. This could be a summary of that chunk for question answering task. It could be an answer based solely on that chunk. Then a different prompt is run to combine all the initial outputs. This is implemented in the LangChain's MapReduce document chain. So pros are can scale to larger documents and more documents than stuff. The calls to the LLM on individual documents are independent and can therefore be parallelized. And on the con side, requires many more calls to the LLM. And the last one is refine. This method involves running an initial prompt on the first chunk of data, generating some output. For the remaining documents, that output is passed in along with the next document, asking the LLM to refine the output based on the new document. Okay, so you got the point. For smaller document, we can use stuff. For larger or more number of documents, we can use MapReduce. But MapReduce will have multiple calls to the LLM. So for this one, although our document is relatively smaller, I just want to use MapReduce so that I do not exceed the overall context window length of the LLM, because we are using GPT 3.5 Turbo here, which I think here by default has a 2K context window length. And my 2 pages of PDF probably will not exceed that, but still I don't want to take risk by that is, I want to make as many calls to the LLM as possible as needed here. That's all right, but I don't want to miss out any part of the document. So I'm not using stuff. I'm not using refine as well. I'm just using the MapReduce. Okay. All right, with summarization chain, I have two sub nodes. So the first one is model. Here as well, I'm going to use chat OpenAI, and GPT 3.5 Turbo is okay. My API is already connected. Add option, sampling temperature. I want to give just 0.1 because I don't want the model to be too creative or random generation. So I want exact answer. Okay, that's fine. And then the document. For document, here it's a PDF document and I want to summarize it. And I'm going to, for this one, I'm going to use binary input loader, then JSON loader, PDF loader. We already discussed this earlier, that there are so many loaders which reflect all the loaders that LangChain provides. But this is a PDF document, so I'm just using that. Okay. And the binary input loader, that also needs another sub node text splitter. And again, I'm going to choose recursive character text splitter. Chunk size, let it remain 1000, and chunk overlap, let me give 50. Okay. All right. With that, I'm kind of done for this part. The next one, I just want to add a conversational agent. So go to agents and conversational agent. Okay. Run once for all item, run once for each item actually. That's what I'm going to select. Only changes I want to make is JSON.answer. Sorry, that would be question. And I'm getting this question from the JSON input. We will see why right question here, because when the input that this node will get in that JSON, there will be question. So that's why I am typing question here. Okay, and in the prompt, in the system message, I want to just add, because this paper is a deep learning based paper, and I want to ask question based on this, and I want the conversational agent to be an expert on this subject. So I just am adding act as a world famous deep learning engineer. And then do your best to answer the question. Feel free to, okay, yeah, that looks all right. And this again needs quite a few sub nodes, but I do not want to give any memory here because I do not need it to remember the old conversation. It is not really a chatting that I'm doing here. And output parser, that also I will skip for now. For the model, I'm going to add chat OpenAI, add option again 0.1. And then tools. For tools, it can again search Wikipedia tool. Okay. Yeah. All right. Looks like I am done, but I actually forgot to include one step here. Actually, that's a very important step, but let's include it now. So this conversation that I'm doing, I want to do this conversation on a previous output. All right. And that output will be from LangChain AI structured output chain. So let's go to chains, structured output chains. Okay. We will come back to these input text and prompt later, but first place it here. Okay. Let's delete that. Let's place it here, connect it here, and the output of this will go to the conversation agent. And model, again, I choose chat OpenAI, add option, sampling temperature 0.1. Yeah, looks all right. Now let's start executing part of these nodes. So execute the Google Drive first. Yeah, it got executed successfully. Then execute the summarization chain as well. Execute node. Yes, perfect. It got summarized, and it got me the summary as a response.txt. And so this is the result of the summarization chain from LangChain, and we can see the schema JSON. I have response, then text. This text is the summary of the entire document. Okay. And yeah, so we can see all these green tick marks. That means this part I actually manually executed. I could execute right from here, execute workflow, but in that case, the entire screen, whatever you see, all the nodes will get executed. But what I wanted to do, I actually wanted to know what would be my prompt or the JSON format here. So for that, I needed to execute all these nodes previous to this node, so that I can see the output of, I can see the input that this node is getting from the previous node. All right. So that's the reason I executed all this part. And now let's see what my parameter configuration will be for this node. So you just double click on it. And so this is the input that is coming to this node. And we can see the JSON here, that's response.txt. So you can directly do, just drag this to here. Actually, just for simplicity, delete entire thing, and then drag this text into here. And you saw beautifully it already formatted json.response.txt. That's what it will give. And what the prompt in this case, I want 3 questions that this node, that is a structured output chain, this node should give me 3 questions for 3 topics based on the summary. So please give me a list of 3 questions based on the previous summary. I actually want to be even more specific that I want the question to be very relevant for this topic that for the summary topic that they generated from the PDF. So let me put that as well. So what I'm saying is, ensure the questions are very relevant to the topic. Think step by step. Okay. Now here JSON schema. So that's because it's a function calling of OpenAI API. If you are familiar with the OpenAI API structure, then you know that here I have to give a perfectly formatted JSON schema. So I have it saved somewhere. So I'm just going to copy that and paste it here. Yep. So this is the output schema that this particular node should produce. You can just go to OpenAI's documentation and read more about this JSON schema stuff when you are doing function calling with OpenAI API. So basically, again, in this particular schema or in this particular structure, we will be adhered to in the output part of this node. Okay, now you're getting the picture that what I'm doing. I am first getting the whole PDF in this node, then summarizing the PDF, then asking this particular node to generate 3 questions based on the summary. And then finally, the conversation agent, what I'm going to do, the 3 questions that it generated, I want to answer those 3 questions by the conversation agent. So conversation agent will just read the 3 questions that it got from the previous node and will answer those 3 questions. So my prompt should be accordingly like that. So I just have to change the prompt here. So as a world famous deep learning and LLM engineer, do your best to answer the question. Feel free to use any tools available to look up relevant information only if necessary. Okay, so that's the whole workflow and the whole plan. And now I'm ready to run the entire workflow. So I just execute this workflow. What that will do is run the all the nodes. Okay, yeah, it started from the beginning, Google Drive, and then it will go to summarization chain. Then once it is done, it will go to structured output chain. Yep. And actually, I also wanted the output from this node to be in a proper list formatted way. So let's just do that. LangChain AI, just include item list so that it's properly formatted, split out items. Okay. And yeah, so let's delete this one, bring in here, connect it to here, and then further connect it to there. Now, yeah, so now for the parameters, we can see the JSON output here. It is response.questions. All right. So my field will be like this, response.question. Let's just do like this, split out items here. And yeah, so yeah, that looks all right. Now, just run this. Okay. After the item list is run, now also run this. You can see how this for chat OpenAI and Wikipedia, this is happening one by one because there's a conversation going on between Wikipedia and chat OpenAI whenever it is needed. Yeah, awesome. So this node also got completed, right? All right, now the execution of the nodes are all done, and let's see what is the summary it produced. So I'm just double clicking on the conversational agent, and here are my questions, the 3 questions that it generated based on the summary of the PDF that I originally gave. And then I asked it, remember our instruction was that for each of the question, it has to define what these are, and it can search the Wikipedia tool for generating the answer, that is for each of the question, to explain each of the question. So let's see what they produced. So the first one, how reliable are current disinformation detection technique in detecting LLM generated disinformation? That was the question, and the output is the reliability of current disinformation detection techniques in detecting LLM generated disinformation can vary disinformation detection technique have evolved over time, leveraging advancements in machine learning and artificial intelligence. However, LLM-generated disinformation can be challenging to detect due to the sophisticated nature of the technique used. And it goes on for explaining the first question. And the second question is, can LLM be adopted to detect disinformation generated by themselves? For that question, I have the answer here. And for the last question, what alternative solutions can be considered if both current detection techniques and LLMs fail to detect disinformation? The answer of that is here. And again, remember, all these answers were produced by GPT 3.5 using the Wikipedia tool. So we can see this entire quite complex workflow with LangChain I did and executed successfully and got results without writing any single piece of code. So that's quite wonderful. And of course, remember, the LangChain integration was done absolutely just few days back. So they are still in development, and more modules of LangChain will be properly integrated, because LangChain now has become quite a bit of large ecosystem. So you can expect more fine-tuned or more refined version of these within few more days. And overall, n8n provides features like custom scenario building, integration with any app via custom HTTP request, painless debugging, and hosting on your own infrastructure. So it's positioned as a core tool to pump data across your tech stack, with use cases ranging from customer integration to CRM customization tool, etc., etc. So do give it a try.